Hello students, myself Dr. Sarika. Today we are going to study about thermochemistry part 4. We have covered most of the part of thermochemistry class 12th. First, in this chapter, today we will study what is a change in enthalpy. In a chemical reaction carried at a constant pressure is the heat that is exchanged between the system and the surroundings. It is denoted by delta H. Earlier, scientists has developed one reaction only, and there was no awareness about the delta H. That till that time it was aware only H. H is the enthalpy. But there was no value of enthalpy in thermochemistry because we cannot calculate exactly what what is happening there. But slowly by the research, scientists developed the equation delta H is equal to delta U plus P delta V. Difference we can calculate easily. So this reaction has revolution in the field of thermochemistry. First, we will go through what is the enthalpy change of a reaction, that is called reaction enthalpy. In a chemical reaction, reactants and products reactants converted to products, and they are represented by the reactants and products. This is called the enthalpy. The enthalpy change accompanying a reaction is called the reaction enthalpy of that particular reaction. The enthalpy change of a chemical reaction is denoted by delta H R. Delta RH is equal to sum of the enthalpy of the product minus sum of the enthalpies of the reactant. What is the standard conditions for the standard enthalpy of reactions? Enthalpy of a reaction depends on the conditions under which a reaction is carried out. It is therefore necessary that we must specify some standard condition. Number 1, pressure should be constant. The standard enthalpy of reaction is the enthalpy change of reaction is the enthalpy change when all the participant substances are in their standard states. They should follow the NTP rule. The standard state of a substance at a specific temperature is its pure form, that is at 1 bar. For example, the standard state of liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar. Standard state of solid iron is 500 K is pure iron at 1 bar. We denote standard enthalpy of reactions, that is delta H. We calculate the enthalpy means there is a difference between two stages, product and minus reactant. So means something is happening there, means some transformation is there. So now we will calculate what is the enthalpy change during phase transformation. What is phase transformation? It is defined as the enthalpy change that accompanies the conversion of 1 mole of a solid substance into the liquid state at its melting point. For example, when 1 mole of ice melts at 273 Kelvin, the enthalpy of fusion is 6 kilojoule, indicating that it is an endothermic change. Phase transformation also involves energy chain. In short, it requires heat for doing action. For example, ice for melting into water. The enthalpy change that accompanies melting of 1 mole of solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion. It is denoted by delta fusion H. The amount of heat required for vaporization, that is called the enthalpy of vaporization. Means if we want to vaporize 1 mole of water into 1 mole of steam. Standard enthalpy of formation. The standard enthalpy means there is a change for the formation of 1 mole of a compound from its elements in their most stable states of aggregation is called standard molar enthalpy of formation. अगर कोई कंपाउंड अपने एलिमेंट से बन रहा होता है तो that enthalpy is called the standard enthalpy of formation. It is denoted by delta FH. Thermochemical equation. What all rules we follow during the writing the thermochemical equation? It should, first of all, it should be a balanced reaction, product and reactant. A balanced chemical equation together with the value of delta RH is called the thermochemical equation. Point to remember in thermochemical reaction, the coefficient in a balanced thermochemical equation refer to the number of moles of substance of reactants and products involved in the reaction. The value of delta RH refers to the number of moles of substance specified by an equation. Standard enthalpy change, that is delta RH, will have the unit kilojoule per mole. Now we can say in the simple words, for exothermic reaction delta H is negative and for endothermic reaction delta H is positive. Unless otherwise mentioned, delta H value are given for a standard state for a substance, that is means when reaction occurs at 298 Kelvin and standard pressure. The coefficient of the substance of the chemical equations indicate the number of moles of each substance involved in the reaction, and delta H value given correspond to the quantities of material. For indicating the physical state of each substance in a chemical equation, designations such as gas, solid, liquid and aqueous are given along with the chemical formula of reactants and products. In case the coefficient in the chemical equation are multiplied or divided by the factor, that the delta H value must also be multiplied or divided by the same factor. When a chemical equation is reversed, the sign but not the magnitude of delta H value is changed. In other words, a reaction that is endothermic in one direction will be exothermic in the reverse direction. Next is the Hess law. Hess law of constant heat summation. The law states the total heat change delta H accompanying a chemical reaction is the same whether the reaction take place in one or more steps. It means that the heat of a reaction depends only the initial reactant and the final product and not on the intermediate products that may be formed. Hess law of heat summation may be represented by delta H is the total heat enthalpy change, and whatever stage it has crossed, we have to summarize that. Delta HA, delta HB, delta HC, etc. Where A, B, C refer to the balanced thermochemical equations that can be summed to give the equation for the desired reaction. We can say the enthalpy is a state function. We know very well this is a state function. This does not depend on the path. Whatever path is there, it doesn't matter. It depends on the initial stage and the final stage. In other words, enthalpy change for a reaction is the same whether it occur in one step or series or a sequence of steps. If a reaction take place in several steps, then its standard reaction enthalpy is the sum of the standard enthalpies of the intermediate reaction, into which the overall reaction may be divided at the same temperature. We can see with this example, in general, if enthalpy of an overall reaction is A of reactant and B is the product along one route, only one, if we follow the one route, that it will be delta RH. If we follow the different rule, then there will be the sum of the all the routes, means delta RH is equal to delta RH1, delta RH2, whatever rules are, whatever paths are there, we have to summarize. What is the standard enthalpy of combustion? Combustion mean it is defined as the enthalpy change per mole of substance. All the reactants and product must be in the standard state at a specified temperature. These are exothermic in nature. Standard enthalpy of combustion is defined as the enthalpy change per mole of a substance where it undergoes combustion and all the reactants and products being in their standard rates. It is denoted by the delta CH. What is the standard enthalpy of atomization? It is defined as the enthalpy change on breaking 1 mole of bonds completely or to obtain atom in a gas phase. In case of diatomic molecule, the enthalpy of atomization is also the bond dissociation enthalpy. The enthalpy change in the process of breaking a bond is called the standard enthalpy of atomization. In the simple word, we can say it is the enthalpy change on breaking 1 mole of bonds completely to obtain atom in the gas phase. It is denoted by the delta AH. What is bond enthalpy? Bond enthalpy in thermodynamics is divided into two parts. First is bond dissociation enthalpy and second is the mean bond enthalpy. The bond energy is the amount of energy necessary to break bonds in 1 mole of a gaseous covalent substance to form product in the gaseous state. For example, the bond energy of hydrogen bond hydrogen in hydrogen molecule is 435 kilojoule per mole. The value of delta H change in enthalpy in terms of bond energy may be calculated as delta H is equal to bond energy of reactants minus bond energy of products. Remember that this relationship is approximate and is valid when all substance, reactants and products in the reaction are in the gaseous state. We can take the example for the diatomic molecule. For diatomic molecule, the enthalpy change involved in the process is the bond dissociation enthalpy. The bond dissociation enthalpy is a change in the enthalpy when 1 mole of covalent bond of gaseous covalent bond is broken to form product in the gas phase. For the polyatomic molecule, in this case, we use the mean bond enthalpy of carbon-hydrogen bond. Their reaction enthalpies are very important quantities, as these arises from the change that accompany the breaking of old bonds and formation of new bonds. This relationship is particularly more useful when the required value delta RH are not available. The net enthalpy of a reaction is the amount of energy required to break all the bonds in the reactant molecules minus the amount of energy required to break all bonds in the product molecules. This is only possible in gaseous state. What is enthalpy of solution? It is defined as the enthalpy change when 1 mole of substance is dissolved in a specific amount of solution. When an ionic compound is dissolved in a solvent, the ions leave their ordered position of crystal lattice and are more free in solution. Enthalpy of a solution of a substance is the enthalpy change when 1 mole of it is dissolved in the specified amount of solvent. The enthalpy of a solution at infinite dilution is the enthalpy change observed on dissolving the substance in an infinite amount of solvent when the interaction between the ions are negligible. When ionic compound dissolve in a solvent, the ions leave their ordered position on their crystal lattice. These ions now become more free to move in the solution. But solvation of these ions also occur at the same time. We can go through this example. This picture shows the hydration of water. The enthalpy of a solution, that is AB, delta solution H in water is therefore determined by selective value of lattice enthalpy, delta lattice H. The enthalpy of hydration will be sum of the path. From whatever path is there, what is the initial stage and final stage, it will depend on that only. So delta H solution is equal to delta lattice H plus delta hydration H. What is the lattice enthalpy? It is the enthalpy change which occur when 1 mole of an ionic compound dissociates into its ions in gaseous state. Lattice enthalpy is difficult to determine directly by experiments. Hence, indirect method is used where we construct an enthalpy diagram, that is called the Born-Haber cycle. The lattice enthalpy of ionic compound is the enthalpy change which occur when 1 mole of an ionic compound dissociate into ion in its gaseous state. Since it is impossible to determine lattice enthalpies directly, so we are using the process, that is Born-Haber cycle. Thank you. Good luck. All the best.